In this lecture, you learn how to use this 16 by 2, meaning 2 lines, 16 characters for each line, LCD display, liquid crystal display. It's a very common type of display that you'll find in many Arduino projects. And in our case, in our project, we are going to use this LCD display to show temperature and humidity that's coming out of the DHT11 sensor, which you learned how to use in the previous lecture. So as you can see here, I've already wired up the LCD display. I'm going to talk about the wiring and the details in a moment. But once we do that, once we learn how to do the wiring, there's a few different ways to do that. We'll come back, talk about the sketch, and then show some demonstration text on the LCD screen just to ensure that it is working properly. Okay, let's go over to my computer, talk about the wiring options and the sketch. Now let's have a look at how you can wire and program the 2x16 LCD display. The way that we'll be connecting this display to the Arduino for our project is the simplest way. It uses more wires in order to pass the data through from the Arduino to the LCD display, but it is the simplest possible wiring because it does not require the use of any additional hardware. I'm going to take a step back here just to talk in general about displays. I wanted to mention so that you know that there are many different types of displays that you can use with the Arduino, just like in electronics in general. The LCD display or liquid crystal display is probably the simplest way to display characters, meaning text, whether numbers or letters or even symbols. You can do all that with the LCD display. There are other types of showing information to the user from the Arduino. LEDs, for example, or LED alphanumerical displays are also possible. And of course, there are dot matrix displays that are very good at displaying graphics using small, tiny dot pixels. If you want to learn more about some of those displays, you can refer to my other course, Arduino Step-by-Step Getting Started. And I've got a dedicated section on the liquid crystal display and also on Arduino Step-by-Step Getting Serious, where I show different types of displays, including dot matrix and LED type displays. Now let's turn back to the current course. The 2x16 LCD display that comes with the 3-in-1 kit. If you turn it around, you'll see it looks like this. The one that we'll be using on its back, if you turn it around, you'll see nothing other than the pins and the various bits and pieces that are mounted on the PCB. So this black module that you see here in this photo is a I2C backpack. This converts these pins, you can see there are 16 pins that are coming out of the base model, the base LCD module, into just 4 pins for the converted module, which is the LCD module with the black backpack module that you see here. What this allows you to do is to simplify the wiring in terms of the number of wires that are used. In our example, and I'll explain why in a moment, we will be using most of the pins that you see here at the back of the LCD display module. Whereas if you use this black backpack, you only need 4. 2 are for power, and then the other 2 are for I2C data and their clock. So wiring-wise, this is a much better way to go about connecting the LCD to your Arduino. The problem there is that if you go with the I2C backpack that you see in the bottom image, the footprint of your sketch becomes bigger. And along with the other things that we want to be able to do with our sketch on the Arduino Uno, in my experiments, I ran out of memory. And therefore, I wasn't able to use the I2C enhanced LCD display with my Arduino. And again, being able to also do things like communicate with the internet and the Blink platform and being able to read from the DHT sensor all that took space, memory space, storage and RAM on the Arduino Uno. And once I put the I2C backpack capability on the LCD screen, it just became too much for the Arduino to handle, and then the sketch just didn't work. So I decided to go with the so-called traditional way of connecting the Arduino to the LCD module, and that is to use the 4-bit parallel mode. With this particular LCD screen, we can use two different parallel modes, 4 bits or 8 bits. If we go with the 4-bit mode, we need to use 4 data pins. And if we go with the 8-bit parallel mode, then we need to use 8 pins for our data. And in terms of wiring, this is what it looks like. So I've got two different versions of the same wiring. One, I'm using Fritzing, which is a little bit more representative, more graphical. The other one, I'm using a KiCad schematic. But in either case, you can see that in 4-bit parallel mode, these green wires are the data. So you can see I'm using 4 of those. If I had used 8-pin parallel mode, then I would need to use another 4 of those pins and another 4 pins on the Arduino to do the connection. Obviously, that wouldn't allow us to connect anything else, because with the Arduino Uno, we would have exhausted pretty much all of the Arduino's digital pins. So we are going to use 4-bit parallel connection mode for this LCD display. So the way that we'll do the connections, starting with the data pins, you can see here the pin name is not written here, but this pin right here is D7 on the LCD module, and that goes to Arduino's digital pin 2. Then we've got pin 6, 5, 4, and the remaining are 3, 2, 1, and 0, which we will leave unconnected since we are only going for the 4-pin parallel mode connections. So the 4 pins from the LCD module are connected to the 4 digital pins on the Arduino, digital pins 2, 3, 4, and 5. So apart from the data pins, we'll need this pin right here. This pin here is the reset pin, which will connect to Arduino digital pin 12. And there is also the enable pin. This pin right here is the enable pin, and that's connected to digital pin 11 on the Arduino. Then we've got the potentiometer that you learned about in a previous lecture. We'll use a potentiometer to control the contrast of the LCD display, and connect your potentiometer so that there is power, 5-volt power going to the leftmost pin. The other one on the other side goes to ground, and the middle pin goes to this pin here, which is the third from the left, which is VO on the LCD module. So VO, and that controls the voltage, essentially, that controls the contrast of the LCD display. Then we've got ground. This is the VSS pin, we'll just connect it to ground. The VDD pin, power connected to 5 volts. We've got the read-write pin that's permanently connected to ground. And finally, on the other side, we've got the A, this is for the backlit. This is the A anode pin for the backlit, goes to the 5-volt power rail, and K for the cathode that goes to the ground power rail on the breadboard. And finally, just connect those two power rails to 5 volts and ground. And that's it with the wirings, which I have already completed on my breadboard. In terms of the sketch is very simple, and it's using the Liquid Crystal library that comes built into the Arduino IDE. So you're not going to have to install it separately. So the Liquid Crystal library, if you search in your library manager, is this one here, already installed. You can click on more info to go to the documentation of this library, and it looks like this. I have simplified this sketch so that it only contains the absolutely essential components to drive the screen, but you can see the other functions that are available. For example, the functions that I'm using in this example sketch are just a constructor here for the liquid crystal, which is this line of code here, and then begin to start the LCD display, and then print out something like that, a bit of text in this case. And I'm also using set cursor, so I can set the cursor to an arbitrary position on the display. If you drill into these functions, you get more information about them. So for example, set cursor, you just need to pass the column and the row. So in this example here, I'm going for column 0, so it's the leftmost column, and row 1, which is the bottom row in the display, since we've got 2 rows only. And that will set the cursor to this position, and after that we'll be printing some numbers here that represent a number of seconds since the Arduino started in this point. But there are other functions as well that you can look at and experiment with. You can get, for example, text to scroll to the left or to scroll to the right, or automatically to scroll if you are writing, for example, text that is more than 16 characters. You can use auto scroll to get that text to scroll across the screen. So here's a documentation that you can experiment with. Of course, you can go back to Arduino step-by-step getting started to learn more about this LCD display, including how to use the I2C adapter and communicate with the display using the I2C protocol, and therefore a lot fewer wires. All right, so here's a sketch. I will go ahead and upload it to the Arduino and see how it works. Okay, so I've assembled the hardware. The sketch is ready to go, so I will go ahead and upload it. And there you go. I'm just going to turn this around so you can see the text. So I've got the fixed text in the first row, and then I've got the number counting up, number of seconds since the Arduino began its latest operation, that is printed in the second row of the LCD display. To change the contrast of the display, you can just use the potentiometer, and you can see the effect that that has on the display's image quality. And that's about it with the LCD display. You now know everything that you need in order to use this display to show environment data from the DHT11 sensor.